guys, welcome back to my channel, and today we're doing trigonometry. Before I waste your time, and please, if you're not subscribed or you didn't like our page, please make sure you do like our page on Facebook and then you subscribe to our YouTube channel. So we're doing trigonometry, but on the trigonometry I want to first explain the right angle triangles, because that's another part that we'll be using a lot. So we all know that the right triangles have three sides, obviously, because they are all triangles, you know. Just a mere triangle, they have three sides and they have three angles as well. And then one of the angles is equal to 90. That's how they differ now to the other triangles. And all angles inside it sum up to 180. So including the 91. And then it means the other two unknown ones will also give you 90. So Pythagoras theorem can be used here for the sides, and trigonometry can also be used for both the sides and the angles. These are the triangles I'm talking about. Obviously they have three sides, 1, 2, 3, ne? And also they have three angles, which is angle 1, angle 2, and angle 3. And I said one of them will be 90, which is that 90 angle. And then here we have our 90 there, and then also on the other one it's 90 there. So it doesn't matter, you just look for that perpendicular sign. As long as this one is cut through straight, it looks like it comes in the middle, and then you see, as long as you see this angle, then you know there's a 90 there. So this 90 plus angle A plus angle C will also give you what? 180, like we spoke about. Yeah, because this one is 90 already. Then if that one is 60, then this one means it's 30. Yeah, even here. So now what we look at here, the angle of 90 is always across or opposite the longest side of this triangle, which is called the hypotenuse, written. So I'm sure you know it, you've been taught in class, ne? So if you're saying the opposite of this one, it will be the hypotenuse. And the opposite of angle A there in the top will be this small letter A on this side. And the angle opposite C will be somewhere. Sorry. I bought marking pens, but I don't know if they're working. So this is your angle C. Ne? It's across that small C, which is the entire side here. Ne? I'm sure you know this one, but if you do not know, do not worry, we'll do it together. Now let's go. Remember SOHCAHTOA, I'm sure you've been taught these things, but let's just make sure we recap. SOHCAHTOA means sine is equal to opposite over hypotenuse, and cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. Look how it's done. So in this one, sine A, where is our angle A? There at the top. So sine, we said it's opposite over hypotenuse. Which one is the opposite? The opposite side of that angle A will be A, the small letter A, and all over the longest side, which is B. So sine A will be equal to A over B. And then cos A, we're looking for adjacent. La angle. Remember, this angle will be between the hypotenuse and one side. So the side where yamengalo will be C, which is your adjacent, C over B. B was our hypotenuse. And then tan will be opposite over adjacent. So opposite ka A ngubani ngula A umncinci. Adjacent wakhona ngubani ngu C. There it is. And then you carry on. Sine B, if you uthatha lo B ukweliqala uzawubona sine B is about opposite over opposite, because the hypotenuse it was that opposite side, then giving us ntoni ke ngoku B over B, which is nabo ucofa icalculator uzawubona sine 90 will give us 1. And then adjacent, which side is adjacent here? Uyabona zininzi, so that is why this one gives you 0. Nalapho uzawuthi cos xa ucofa icalculator uyamazi cos 90 is equal to 0, so don't mind about that one, they'll never ask you such. And then tan B, or undefined, which is tan 90. Now, for yourself, please make sure you do ulanduka sine C no cos C notandi according to the diagrams that I drew there. So because you are alone at home, so you can somehow pause and then just copy the diagram quickly and then make sure you try these ones, and then if you get them right, you're good to go. Now let's check Pythagoras theorem. What does it say? So what do Pythagoras theorem? The sides. Pythagoras theorem, remember I said it speaks about the what? The sides. Yes. So side A, side A, side A, side B, what? So it says this A plus B will give us C. Okay, let's say this is B, then this is C. So it says the longest side squared will be equal to the shorter side squared now. So it's going to be A squared plus a C squared is equal to a B squared. Don't say A plus B is equal to C. No, you must square them. Then it is shorter sides, no longer sides. Don't ever forget that one. So the longer side is always opposite to 90. What I said, the other part. Now here, I've got a health warning. You cannot survive if you forget this one. This right angle triangle can be drawn anywhere on the Cartesian plane. Meaning it can be drawn on the first quadrant, on any part on the 4 quadrants that are there, and it changes terms depending on the quadrant it is on the Cartesian plane. The Cartesian plane gets unbonus on the next video, but I'm sure you know what it is. But then this one you must make sure you know it. But like when you quadrant change, not the rules of course, but you must, there are certain things that you really have to take note of. So let's take an example. We also here we have a right angle triangle because we have angle B where to being 90 degrees. So in order for this one to be a right angle triangle, and you are sure as angles zonke, all these 3 angles must give you 180 degrees. So let's see if it's at 190, 90 up plus 30 plus a 60. Definitely this will give us 180 because 90 plus with 30 plus this one will give us 90 plus 90, 180. So already this one is already good. And then that the longest side must be longer than these ones. So we have a 2 there, and then upper small 1. Definitely whatever we're trying to find here must be less than 2 because stay longest side here to ile. So nansi root 3. Nobo ngamcofa root 3 calculating uzambona less than 1. The square root of 3. 1.7 less than 2, I mean. 1.7 angoku. So that is a right angle triangle. Senza umzekelo apho sin C, sithatha sin C, where is C? Here is C, masebenzele green. Nanku C. C opposite wethu ngubani? Ula small letter C. Starting opposite over hypotenuse ka senza sine. So which is C over B nangu B wethu. So it's about 1 over 2. Already sin C we know is equal to 1 over 2. And what is C? Siyamazi C wethu ngubani? Sine 30 must give us 1 over 2. Never make the mistake of writing this one as sine, because I think I used to do that when I was still younger. Dithi mhlawumbi sine 30 phinde kwami ndizibone it is equal to sine 1 over 2. You might end up now taking the wrong thing into the calculator or sending the wrong, but the sine is equal to the singular number. So this one would be definitely wrong. So wrong. So take note of how you're writing maths, because I feel like some of you are only failing because you write the wrong things that will later confuse you. And so again, when I calculating, you will see. Let's quickly sum up this video before it becomes long. Now use all the rules I taught you to prove all the other sides and angles are correct according to that diagram. Because it has that 60, the 30, and the 90 Yeah, no 1, no 2, no root 2, no root 3. So you can somehow draw that again. So xa siphinde sijonge ii-sides ke ngokuba is Pythagoras working now. A squared sathi plus C squared is equal to bani? B squared. So sijonge. Elokuqala iside ibingu-root 3 plus 1 will give us a 2. So root 3 squared will give us a 3, 1 squared will give us a 1, and then 2 squared gives us a 4. So 4 is equal to 4 right angle triangles. We show off that. Let me cut it before it becomes too long, and then we'll finish the other chapters in the next video. Thank you. Don't forget to like and subscribe.